right, test 1, 2, okay. So, good morning everyone and welcome to my talk on the Spring ecosystem. So I'm glad you guys showed up here. Contradictory on what is set on the schedule, I will not be talking the entire day. So this will only be 50 minutes, although I could talk about this whole day, I guess. And while preparing for this talk, it was quite a challenge, and even more when I went through the different projects and I found out different sub-projects and related projects and stuff like that. It became more and more like a mission impossible at first for me. So we'll be talking about this in 50 minutes. It's quite short, it's quite a challenge, but still I will try to give you a good overview of the different frameworks, the different projects there are. And I was really glad to have the opening speech talking about what Spring can do for us, in fact. Really adapting to change, allowing us to give choice on the different things that you want to use, but using this choice wisely and making sure that you use the right frameworks for the problem that you have. And so I will try to go over most of these frameworks and try to give you an overview for what kind of problems they try to solve for us. Now, a little bit about me. I work for a Java consultancy company in Belgium, where I do a lot of Spring projects. And I'm also a Spring certified instructor. So I give a lot of Spring Core, Spring Web, and Spring integration trainings in Belgium. You can find my Twitter right there. So after this talk, I will also be publishing this talk on my Twitter account. So a little bit about the agenda. We're going to have a little introduction on the Spring I/O projects, telling a little bit about the different kind of projects there are. And then I made some kind of categories on which I'm first going to talk about classical Spring frameworks or projects, the ones that we are probably all familiar with. And then take a look at the popular ones right now. And the reason why I call them popular, I will explain as well. And then we'll end up with some other projects which are worth mentioning, so that you have an overview of the complete picture, of course, but I will not go into that much detail on those. Now, if you take a look at the Spring I/O website itself, there are about 24 main projects listed there, but there are different kind of projects, you could say. So there are projects, and if you click on these projects, like Spring Security here, you will find there are some related projects. Most of these kind of give you extra functionality regarding adapters, for example, Spring Security in connection with LDAP, with Kerberos, and so on. Now, of course, if we take a look at a framework like the Spring Core framework itself, that consists out of multiple modules, so-called modules. They are like a unit of work describing a certain functionality and having as less as possible dependencies on other libraries. So in the Spring Core framework, there are about 20 modules, and you could say that most of the Spring projects consist out of multiple modules. And then you have the so-called umbrella projects. And these are, well, in this case, a Spring Cloud is one of those umbrella projects. Consists out of different sub-projects. But each sub-project has its own release cycle, so having its own versioning and so on. But, well, it's going to give you some kind of platform, a release train, so-called, where you can bundle a couple of these projects so that you know that the versions that I use here of these different projects, they probably will work well together. And these release trains, they are available as BOM files so that you can include them in your project. And as you can see here in the green, so from all the Spring Cloud projects, these ones are released from time to time in a version which is not a number, but is in fact a name. So you can see here we have the Angel version, and it's alphabetically, meaning that you have the first letter indicating what kind of version this is. So A is the first version, a name that begins with a B is the second version, and so on. And then you can have service releases marked here with the SR and then a version number behind it. So that's mostly when, for example, there is maybe an important bug found in one of the sub-projects. Then they, of course, release a new BOM file, and this is going to be a service release. So those are the different kind of projects, you could say, that we will encounter. Now, the first project that I'm really briefly going to talk about is the classical ones. And of course, the Spring framework itself is at the core of every one of these. And as we all know nowadays, well, Spring 5 that's coming out probably this summer is all about this reactive stuff. So that's a lot of talks on this conference will go about this reactive programming model. Now, there are a lot of other things. I'm going to pick some of them. The first one that I want to pick is the Spring I/O platform itself. So again, this is kind of a versioned release of different Spring projects that work well together. And you don't really have to worry now which ones will work together. You just include this BOM file in your Maven code, and then you declare the dependencies that you want, and you see there is no version defined here. So the version, it will get that from the BOM file itself, and so you know now every dependency that I now add in my project is well tested in front, will probably work well together. So that's a really handy thing, and also the Spring Boot platform makes use of this kind of BOM files. Spring Security, as I said before, contains some related projects, as you can see here, for integration with different kind of security systems. It's a framework that we're using for authentication and authorization, and it has well integration with Spring MVC and servlets and so on. So just to show you here, these related projects, you will find that a lot when you click through the main projects, giving you some extra functionality, some extra adapters, and so on. Of course, Spring integration, probably have heard of that as well. Our applications these days, they don't live on their own anymore. They have a lot of integration with external systems. So the problem is here that, well, the problem that we are trying to solve is this kind of enterprise integration patterns. And so they are available to do a lot of integration with external systems. So an implementation of that is in the Spring integration project. And you have a lot of adapters for external systems, for including file system, for including REST, GMS, and so on. And there is also a very nice thing that you can decouple, in fact, the things inside your application very good because there is a sort of lightweight messaging system inside Spring integration itself. And the real neat feature that I think is that there is also a DSL available for this. A DSL that's, well, allowing you to write in a very understandable way the different flows that you have in your application. And you can almost think of this as the functional style of programming where you go through this flow and you can see what's going on here. Now, very short, some other of these classics. We have the Spring LDAP integration project, meaning that you can have well, an integration with LDAP, get some information out of there, allowing you to have a template like we have with the GDBC template, for example, for making this integration. We have Spring Webflow, which is all about stateful applications, allowing you to define wizards. It's not really used that much anymore, I think. And also the evolution on this project, well, I think it's a couple of years now since there has been a new version of this one. So probably not that used anymore. And then we have Spring Batch, allowing us to do long-running jobs, offering support for that one. And we have integration with web services and the possibility to write our own web services. Following the contract-first approach and so on. So these are the classical ones. You probably have heard of most of those. Now, what I want to talk about in a little bit more detail is the popular ones these days. And why are these popular? Well, it's mainly because our application architecture has changed a lot since the beginning of Spring. And as said before in the keynote, we have to adapt on that. There are a lot of Spring projects that are existing because of new features, of new architectures that exist. And if you look at the web part, for example, there is a lot going on mobile devices. We have responsive website. We have thin versus thick lines with REST interfaces on the backend. So we have, of course, some adaptation to do to make sure that we can include this in Spring as well. Also, if you take a look at the cloud environment, a lot of things going on there. So yeah, we'll have to see how we can focus on that one as well. Integration, we have already talked about Spring integration, but there are a lot of other integrations possible as well. And of course, on the data layer here, there's also a lot has changed here. So we have these NoSQL databases but you have also in cloud environments distributed databases, allowing you to, well, interact with those ones. And of course, Spring has this model to do that and make this kind of abstraction for you, as you will see with the Spring Data Framework. So let's fit all these frameworks then on this picture. So the first one, of course, is the Spring Boot, creating our microservices, for example, if you have that kind of infrastructure. We have the data layer where we have Spring Data that can help us with that. And on the web layer, we have Spring Session, Spring REST Docs, we have Spring A2S project, and of course, the REST support that we get out of the box if we have the Spring framework. On the integration part, we have Spring Integration, as we talked about before, and we have Spring Social. And then a very big project with a lot of sub-projects is a Spring Cloud, allowing us to do integration with Platform as a Service, but also offering a lot of services around the microservice architecture. So Spring Boot, start.spring.io is a very famous website to get started, or you have the IDE support, of course. Now, why do we want to use Spring Boot? It's a faster way. It's allowing you to get a fast start experience for a new project. And it's going to be opinionated as well, meaning that it's going to have some convention over configuration. So it's going to try to figure out what's going on your class path, what kind of starters you have on your Maven POM file, and that way it's going to already figure out what kind of application you probably want to start up and providing that configuration for us. And of course, there's some other nice features with the embedded servers, for example, where we have executable jars, allowing us to do fast deploys, fast startup of our applications. All right, so we start up an application using Spring Boot, so maybe we want to do some data integration. Now, why is that sometimes a problem? Well, these days we have a lot of databases available, and probably our application maybe uses multiple of these databases. So first we need some kind of integration on that. And the second thing is that we probably will write a lot of boilerplate code as well, writing the CRUD operations every time again and again. So Spring Data will try to solve both of these problems for us, allowing us to give some kind of programming model, an abstraction effect over these databases. Now, Spring Data, again, is an umbrella project, meaning there is a lot of sub-projects available, as you can see here. Most of these projects are focused on integrating with a certain database solution. So as you can see here, we have Spring Data JPA for regular relational databases. We have Mongo, Gemfire, and so on. So most of these are kind of extra frameworks that you can use for doing this integration. And then there's a special one, Spring Data REST, which I will be talking about in a couple of slides as well. Now, two steps that you have to do time and over and over again is the first thing is you have to annotate your domain classes in this model, so as you would do with JPA, for example. And the second one is then that you can define one or more repositories regarding a certain entity that you want to persist. And then we have these predefined interfaces. For example, here we have the CRUD repository from the Spring Data project. And you can just use that one, implement it, or extend it, in fact. And Spring will, at runtime, give you all the CRUD operations out of the box for this entity object. So that's, of course, a very neat solution. And, of course, you can extend that because CRUD operations only are not enough, probably. So you can add extra methods there for providing custom queries as well. So Spring Data REST is one of the sub-projects of the Spring Data project. And it's really about domain-driven design, you could say. It's the challenges that you might have with REST, where you can have a tight coupling sometimes between client and server because you will have to include these URLs hard-coded probably in the client. Well, there isn't a standard for trying to solve this kind of things, which is called, well, I don't know if I pronounce it right, but A2S, that you can use for that, which tries to decouple the client and your server if you do a REST approach. And you could say that Spring Data REST is kind of like Spring Data plus this A2S approach, where we start from the domain-driven design principles. So the domain is, in fact, the starting point. And Spring Data REST will extract all useful REST endpoints for those domain objects that you have in your application. And there's a very interesting talk about this, if you want to get into more detail, from Oliver Gierke that you can see here, one of the main leads on the Spring Data project. So check it out if you're really interested in this, because there's really nice stuff going on here. So I'm gonna skip this one. So Spring Session is really all about solving the problem that we have with traditional HTTP sessions. Especially if you go to a cloud environment, well, then a session that is somewhere in a microservice needs to be shared probably over all these microservices that are available. So trying to solve that kind of issues is really all about Spring Session. And you can choose, of course, to plug in a certain persistence strategy where you want to store this session. And probably if you have a cloud or a distributed environment, this will be a distributed persistence store, like a Redis, for example, that you can use. But it's flexible. You can use all kinds of databases. So if you want to just use regular relational databases, that's possible. And of course, also the more advanced ones, you can just have this kind of adapter interface again, where you can plug in the right implementation, allowing to do that. Now, the nice thing about this is, because this lays an abstraction on top of your HTTP session, is that you can do even more stuff if you want. So you can add extra functionality for doing switch users. So you can have multiple sessions open in a browser, for example. You can use custom correlation strategies. So for example, if you're doing REST, then you probably will have some kind of ID that you need to send over the headers. And it's even possible to keep your session open now during WebSocket traffic, which is also something, of course, if you talk about these very responsive websites, that you really want to do. So just a short one on some other popular frameworks here. So we have Spring 8 OS, as I said before, for trying to decouple the client and server in a REST interface. We have Spring REST documentation, which is very neat because, of course, when you do SOAP web services, you have a contract. With REST, that's not really the case, so you need good documentation on top of that. And the approach that Spring REST Docs uses is that it's going to start from your tests, in fact, allowing us to derive the documentation from that one. And in fact, really able to introspect also the HTTP request and the response object, so that it's really able to see what's really going on. On the contrary, for example, if you have like Swagger, you have to do a lot of annotations inside your code. And if those annotations don't really match up with the REST interface itself, then of course you can get out of sync there. So that's what Spring REST Docs tries to solve by starting from the tests. And then Spring Social, well, Spring Social is in fact 4 main projects, but you can see there are like more than 30 community projects already available, trying to integrate with a lot of common social platforms these days. So you can have integration with Facebook, like Instagram, all this kind of stuff. Just check out all the community projects, because there's probably one available if you want to do that kind of integrations. Okay, so the thing that I want to talk about now is Spring Cloud. And we said that Spring Cloud is a very big project. It contains around 20 subprojects. And there is also Spring Cloud Dataflow and Spring XD, which I will briefly mention. So Spring Cloud, it's really like your toolbox in the cloud, you could say. So you want to do a lot of things there probably in the cloud. You want to do microservice architecture. Maybe you want to do data flow pipelines. Well, the Spring Cloud project offers you these tools to get started with those kind of stuff. These tools will try to implement certain distributed patterns, as you will see later on. Most of these patterns, for example, will be offered also by platforms as a service, like Cloud Foundry. But if you don't want to be dependent on these kind of platforms, you can include them inside your project itself and start a cloud-independent solution there. So again, an umbrella project, meaning there is a release train for this as well. The latest one is the Dalston release that you can see here, containing these projects over here. Now, what I've did is divided them in 3 categories. So the first one that I will be talking about is these ones here, because these ones allow you to do support for microservice architecture. Then we'll talk about data pipeline processing. So there are some projects for that. And then there's integration with the different platforms as a service, So I divided them in these 3 categories, and we will go over each one of them so you can get a good overview. So the first one is about microservices. So microservices, it's really nice to have this monolith being split up, of course, into different microservices. But there's a lot of extra management going on there if you want to, provision that kind of things. Because each of these different microservices, well, you need to keep them alive, of course. You need to know which services are available. Maybe you want to do if something goes wrong, you want to cut the traffic to that certain microservice and so on. So all these kinds of projects here try to solve these different problems that we can have. First thing is, of course, you need some kind of gateway to go in, and you need dynamic routing, for example. So there's Zool that allows you to do that. And as we will see, a lot of these things are based on the Netflix stack. So Netflix open sourced a lot of these tools that it uses itself, and Spring Cloud uses these tools to integrate them. Now, of course, also you need to do service discovery. So there is the Eureka server that you can use for that, or Zookeeper, for example. And of course, it's probably not a good idea to have the configuration spread out over all your microservices. So you can do central configuration as well using Spring Cloud Config, for example. Now, the first 3 projects here, Spring Cloud Zookeeper, Spring Cloud Netflix, and Console. Well, the main project there is Netflix, you could say, where you have Eureka, Zool, Ribbon, and Hystrix. So Eureka is all about service discovery. So every time your microservice starts up, it's going to register itself with this Eureka server, and it keeps a track of all the services that are running at this moment. Zool is the intelligent routing service that you can use, and it's going to be integrated with this service discovery as well, so that it knows where to route all the traffic, of course. Then we have Ribbon, allowing you to do client-side load balancing, so meaning that the client itself is responsible, in fact, for deciding which node it's going to be landed on. And then the last one here is Hystrix, that you can use as a circuit breaker. As I said before, when things go wrong in a certain microservice, you probably want to cut traffic to that one, and that's what the circuit breaker does. It's going to open the switch for you and just say, no more traffic here, and you can have this kind of dashboard here where you can then track all these statistics. Now, Spring Cloud Console and Spring Cloud Zookeeper are more or less the same, you could say. So this is from Apache. This is just another implementation, but they both do service discovery and have distributed configuration so that you don't have to worry about that. So another thing that we have to do, as I said before, is try to avoid this problem of configuration being spread out over the different microservices. So we want to do it centralized probably. And there we have Spring Cloud Config allowing us to do just that. And the idea is that you have integration with your different clients. And every time when they start up, they are going to contact this config service, asking for the newest configuration and using that one in the Spring environment that you can use then to access these variables. And there is even nice tooling available. So if some configuration changes here, you can start asking these different microservices to update themselves. So that's also very neat, of course. And of course, this configuration here needs to come from somewhere. And what you can do is have this pluggable repository system again. So where you choose which kind of repository you want for this configuration. Can be a file system, just as simple as that. But you can as well use Git repository, where you can now have versioning, in fact, also of your configuration files. And most of the times, that's probably what you want to use. Now, another big problem that you can have is that when you have this distributed landscape of your application, it's becoming much more difficult to track if something goes wrong. So suppose you get a phone call from one of your customers telling you that he can't reach a certain screen, or that if he clicks a button, something goes wrong. Where do you need to search? Because there are a lot of microservices doing each part of the work. So that becomes very difficult. You could go over each log file, of course, and see if there is an exception happening somewhere. But it's very hard to find the processing flow throughout your microservices. So Spring Cloud Sleuth will try to solve this problem. And the way that it does that is it's going to attach a correlation ID, you could say, throughout your entire flow of a certain request. And that way, you can now aggregate all your log files, for example, in an Elasticsearch, using this correlation ID as the key, in fact, to find out which logs belong to the same request. And that way, you can much easier go through your distributed system and do debugging, in fact. Of course, you probably want to capture your logs in a central collection service. And so, as I said before, you can use Elasticsearch, for example, to do that. Two other frameworks that I will briefly discuss on the microservices part, and then we can conclude that one, is the Spring Cloud Bus and Spring Cloud Security. The first one is a lightweight message broker. And so we all know GMS brokers, messaging brokers that we have. The only thing is, of course, you don't want to use this one for your just general messaging. This is really all about connecting the microservices together and exchanging some data that they need to manage themselves. So for example, maybe you have some state that changes inside your microservice architecture, or you want to have some instructions sent over from one microservice to the other, then you can use this Spring Cloud Bus to do that. But of course, don't use this for the flow that you have in your application itself. It's not really built for that. So that's the first one. And then the second one is, of course, Spring Cloud Security, where we, of course, need to have security in this landscape. And yeah, you need some way of defining security over these microservices. So some of these patterns that you can use for that, they are implemented using Spring Cloud Security. So for example, the single sign-on ID or token exchange between microservices, that is one of these patterns that is used a lot, of course, when you have microservice architecture. And that is being built in this Spring Cloud Security project. And it's built upon Spring Boot and using Spring Security OAuth to do this kind of stuff. So that's the services here on the left side we discussed for doing microservices. Okay, it's very briefly, but should get you an idea of what's going on in this microservice architecture and get you started with it. Now, a nice thing here that I discovered myself was the data pipeline processing. So we'll discuss that now. So the idea here is that we have this data that keeps on flowing, and we want to do some processing on top of that. Could be, for example, that you're a credit card company and you get transactions in all the time, and you want to do, for example, fraud detection on top of that. So you probably want to figure out maybe that transaction, is it coupled to certain users, and so on. So you probably have this kind of pipeline of different processing steps where you get data in, you do something with that, and you get data out. Now, what you could do, of course, is write an application that retrieves data and has different classes to do this processing as a monolith application. But of course, that's not really, well, it doesn't really give you that much flexibility, you could say. What if we try to get each one of these steps and make a microservice out of them? So for example here, the inputs, we make a microservice using Spring Boot. For each processing step, we do the same, and also for the outputs. And now we get a much more flexible approach, because each one of these services, we can now just react on them just as we would have a microservice in every cloud platform. And you can, for example, say that if this one takes too long, you can start scaling it up, for example. You can do high availability on top of them. You can do all kinds of stuff that you would have in a cloud platform of your entire pipeline, your data pipeline. And that's, of course, very nice. The thing is, of course, that these guys here, these applications, they need to be integrated somehow. And Spring Cloud Data, Spring Cloud Streams, in fact, is going to do just that. So it's going to transform your Spring Boot application into an application that's getting some inputs, does something, and then giving some outputs. And the way that it's going to be integrated, well, there's an abstraction for that. And so as you can see here, the binding between all these ones, you can use Kafka for that, you can use RabbitMQ, but it's just a matter of changing some configuration. And in your application itself, you're just concerned about that input data and giving some output back. Very nice model, and you can use different integration models as well. You can use pub/sub model, you can use all kinds of stuff, all the different approaches that we get to know in an integration model, just by changing some configuration there. Now, of course, we now have these different individual Spring Boot applications, but we need some way now, of course, to run this pipeline. And we also want to avoid, we want to really, we want to aggregate all these Spring Boot applications as one pipeline as well. So there is Spring Cloud Dataflow that does that, allowing us to manage these data pipelines. So first and for all, it's going to do the orchestration for us, making sure that these different applications are started up. And once they are all started up, the data can start running. So it's going to manage a life cycle for us. Besides that, it's also a dashboard. So it's allowing you to have a user interface on top of it so that you get a good idea of my pipeline that is running and see if there are some problems inside one of these steps. And there is also a DSL language that you can use for describing these pipelines. So very neat again, very readable as well. Now, Spring Cloud Dataflow consists out of some other related projects as well. So the dashboard, for example, is this one on top of here. But you can also have integration with Apache Jarn, for example. You can integrate with Kubernetes to make sure that the life cycle of your of these different services handles correctly. You have metrics collector and so on. So all kind of related projects. Again, you pick out the right project for your task. What you want to do with your pipeline. Now, very short mention on Spring XD, because you could say that Spring XD was the predecessor on Spring Cloud Dataflow, and well, it was redesigned in fact. And as of July 2017, this project will end as well. Well, don't use that anymore. Instead, you're probably going to use Spring Cloud Dataflow, which is much more suited for a cloud environment, where Spring XD was not really meant for that. So okay, we have done these projects here. We have done projects that you can use for doing data, pipeline processing, and then the last part here is about integration with platform as a service. So what we want to do here is, well, we want some abstractions maybe to integrate with AWS, for example. As you can see, Spring Cloud has a project for that. And there's also a project, as we will see later on, for Cloud Foundry, of course. Well, some of the features, as you can see here, allowing you to integrate with the cloud-native services that you have on AWS, in fact. So you can use the Spring Messaging API principles for SQS that you have on Amazon. There is also caching, well, the cache abstraction that is in Spring. You can now plug it in in Elasticache of AWS. And so on. So a lot of these features, very neat features. So if you are deploying your application on AWS, might be worth mentioning to go and look at this project here. Also an integration with Cloud Foundry. So one of these features is, for example, that you can now get the credentials which are available in Cloud Foundry itself and couple them together with your Spring application using Spring Security framework. And there's also an integration with the service discovery service from Cloud Foundry that you can use. Now, if you want to connect or if you deploy your application on a cloud environment, then often you will have this kind of marketplaces where you can use certain services. So for example, you have a database that is already available there, and you can just include that service inside your application. And there are different connectors to do just that. So we have the Spring Cloud Connectors project, allowing us to integrate with Heroku, Cloud Foundry, as one of the major projects, of course, and allowing you to have support for relational databases, services, MongoDB, RabbitMQ. So very easy to integrate with these existing ones. There are some extensions from the community available as well, as you can see here for SAP, IBM Bluemix, Amazon S3, and so on. So for most of the most famous platforms as a service, you will probably have connectors available there. And if not, just extend it yourself. You can just as easily write a connector yourself. It's always the same ID. Just have some kind of interface available in Spring that you can implement, have your own implementation available, and maybe you're the next community project available on the website of Spring.io. So it will be really cool. Now, if you want to do that, your own managed service, if you want to create your own managed service, in fact, and you want to offer that on a platform as Cloud Foundry, then there is the Spring Cloud Foundry Service Broker that you can use. So that way, you can, in Cloud Foundry, very easily create your own service, create an application, and offer it as a service in the marketplace, for example. And of course, you need to have some kind of standardization in the API. Well, you can use this project, and it's offering you all these things out of the box. So these 3 categories, I'm going to go briefly over these 4. Spring Cloud CLI is a command line. Well, it adds command line features for Spring Clouds. So for example, you can launch services very easily using a command line interface, and it's very useful at development time. So if you're doing local development and you want a Eureka server, for example, to test it, you can just start a command on the CLI and just start up a Eureka server out of the box. Spring Cloud Contracts, again, an umbrella project. It's really about consumer-driven contracts. So that's a project that you can use for that one. And the last one that I'm going to discuss here on the cloud track is about tasks. And the meaning of this project is maybe you have some microservices that are short-living, meaning that they don't have to be operating all the time. So they just do a certain operation, and after that one, it's just done. And Kubernetes doesn't really need to care about it anymore. It doesn't need to keep it alive. It just can keep it offline at that moment because it has done its work. So Spring Cloud Task, if you have some kind of operations like that, you can use that project. And it's going to execute these processes for us, these microservices in the cloud environment. And you have integration with Spring Cloud Dataflow for this. So Spring Cloud Dataflow allowing us to manage these tasks and run them if you want to. So that concludes the Spring Cloud. There was a lot of projects there, a lot of sub-projects. Again, use the release train if you're interested in Spring Cloud, so that you don't have to really worry about much of the versions that are available. But beside that, you just pick again the sub-projects that you want, depending on the kind of problem that you have. And that's again what we talked about, or what they talked about in the keynote. You really want to see what kind of problem am I trying to solve here, and pick the right tools to do so. So I'm going to go over some other projects just very briefly. This is just again to make the overview complete. You probably might have heard of some of them. Some of them might be quite new. So for example, here you have a Spring State Machine, which is not really well known, I think. Spring XD, well, we talked about that one before, so I'm not going to do that. And there are some integration frameworks here that we will talk about as well. So integration, we have integration with Kafka and AMQP, for example. Well, the idea here is, again, very simple. We have some kind of abstraction that we already know from a GMS support that is available in Spring, for example, where you have this kind of templating system to send and receive messages. Receive here is synchronously, so that's a bit of a problem, of course. And then the solution for that is using listener containers, where you have these message-driven POJOs that you can use for that. Well, that's available in GMS support, and it's the same idea here for Spring Kafka and AMQP. So it's going to give that same functionality with these new message brokers. Spring for Android and Spring Mobile. I here put a picture of the Maven repository. And as you can see, the latest update here was July 2015 for the mobile framework. So it's probably not that used that much anymore. But the idea was that Spring Mobile allowed you to see what kind of device was connecting to your application. And depending on that, you could change your return result that you show to the user. Now, of course, nowadays we have like Bootstrap allowing us to do responsive web design. So most of the times you don't really want to care about all these different kind of devices. You just want a flexible layout that is able to fit on all these kind of devices. So Spring Mobile, well, I think this project will probably disappear from the Spring IO websites anytime soon and be moved to the attic. Spring for Android as well, it allowed you to have this, the idea of the REST template that you have in Spring Core, but then for integrating it with Android and also having OAuth support for doing security. But I think here again, most of this functionality is now available in Android itself. So why should you use that anyway? So Probably also a project, it's still there, but you can still use it. But the development, well, it's kind of stuck there. Then Spring Shell, which is, well, was new to me, in fact. So it allows you to, in fact, write your own CLI interface again and allowing you to provide certain commands that you might use for your project. And for example, you could have, if you want to do testing for a REST interface, you could very easily define some commands here that do certain REST requests and just executing them like that, make it a little bit easier to test your application. So that could be one of the use cases where you want to use Spring Shell for. The way that it does that is, again, you have to create an application where you have a class file, and you annotate it that you want to expose this as a certain command, and it becomes available here in the CLI, where you can do help, and you see all the commands that you can execute. And you already get a lot of commands out of the box for doing some very simple and very commonly tasks, like, for example, cleaning your screen again and stuff like that. Spring Flow, that's in fact a visual tool allowing you to draw this kind of pipelines. And it's in fact used in the project from Spring Cloud Dataflow. So when you define this data pipeline, well, this project is used to visualize that data pipeline. And you have this kind of ability to, in fact, create your own pipeline by drag and dropping the elements that you need. And then it's going to generate the pipeline, a DSL of that pipeline for you. So if you want to, you can even use that outside of the context of Spring Cloud Dataflow. So if you have maybe a project that does this kind of graphical things, you can even use that project for that and not having to reinvent the wheel there. So the last one from these other projects is a Spring State Machine. And that's a very interesting one because this one is going to bring the concepts that you have in a state machine to the Spring project. What do I mean by a state machine is your application consists out of a certain amount of states, and you have this kind of eventing that you can go from one state to the other. So this was already quite commonly known decades ago, but it's becoming more and more popular nowadays for certain applications. And Spring State Machine allows you to define this kind of states and the transitions that you have between these states. And then you have concepts like guards, actions, and so on that you can now start using. So that concludes, in fact, the overview. I hope maybe you encountered some new projects that you now can use. In my case, it was really enlightening to see that, to go over all these projects and to get a little bit into more detail about them. And I already discovered some of the frameworks that I will try to use in new projects as well. So I hope you guys had the same experience. And then, well, that leaves us about a good 5 minutes to have some Q&A. Yeah. All right. So, if there are no more questions, yeah, please. Yeah. So are you talking about the release trains of the bigger projects there? Yeah. Yeah. So of course the first starting point is always the Spring I website there, but there's a very good documentation there available on the different release trains that you have. And as I said before, of course they don't want to have a new release train every now and then because they know also that a lot of the projects really depend on those kind of release trains. So they're really careful about bringing out a new version of this one. It's only when it's really necessary that they will combine again certain versions of the different sub-projects in a new release train. So the main thing there is always check out the blog as well, because there's always a new description of a new release train coming out. But again, it's really depending a little bit. And sometimes it can be a little bit hard because a release train, yeah, you don't really know maybe sometimes what versions are underneath. And so then you have to do a manual process of taking a look at the blog post, seeing what versions are in there as well. So sometimes a little bit of manual work, you could say. Yeah, true. I hope that more or less answers the question. Or okay, so hope you have a nice conference, and thank you for coming.